Hi, my name is Alistair. Welcome to another video on the Completing the Square series. The question we want to ask ourselves is, can we use the first parabola to determine the equation for the second? Now, if xy is any point on the second parabola, that's the one on the right, then xy is the result of translating a corresponding point on the first graph. But this is expressed from the perspective of the graph on the right. So we write that x has been translated to 3 units to the left and y has been translated 1 unit down. And from this, we also know that the point lies on the first parabola and its coordinates satisfy the equation y is equal to 2x squared. We also should note that its origin is at 0, 0, and we can check that by substituting first for x in y is equal to 2x squared and then y, and we see that both x and y are equal to 0. So we substitute for the y coordinate, which is y minus 1, and for the x coordinate, which is x minus 3, rearranging that to give us y is equal to 2 brackets x minus 3 all squared add 1. And this is the completed square form. Now, why do we use the completed square form? Well, there's a quick and easy way to determine the vertex of a parabola. If we express it in general terms, we have h substituted for 3 and k substituted for 1 in the previous slide. It has the same shape as the parabola with equation y is equal to ax squared. We know its origin is its vertex is at the origin, which indicates that it's shifted h units to the right and k units up. So vertex of y is equal to ax squared moves from the origin to h comma k. And so we can conclude that the parabola with equation y is equal to a brackets x minus h all squared at k has vertex h and k. Now these are the two parabolas that I was referring to. Here on the left, we've expressed this point in terms of the translated parabola on the right. So x moves left 3 units and y moves downwards 1 unit. And in general terms, using h and k to replace 3 and 1. Now the parabola translated right by h units and up by k units is the same as saying that it's translated h units to the left from the perspective of the second parabola and k units down. H and k can be positive, negative, or 0. And each coordinate xy on the translated parabola is a translation of the point x minus h and y minus k on the first parabola. As in the specific case, y minus k equal to a brackets x minus h squared rearranged to give our completed square form. And here's an example. The equation of a parabola has been rearranged into complete square form as y is equal to 3 brackets x add 5 all squared add 8. We can read off that h must be negative 5, seeing that we can only have a negative value with another negative value to give add 5 plus 5. and k could be read off directly as 8. So the vertex of this parabola is -5, 8.